So a bit of a technical point about lazy computation. As I've written here, the function range returns a kind of sequence of numbers that's computed lazily, I wrote, as it's needed. That means that in reality, this takes up in the memory the space of one number at a time. So this is important because a for loop can loop a very high number of times. So you can have a for loop that repeats 1,000 times, 10,000 times. And as you realize, if you are in this situation where you actually have to spell out a sequence of numbers explicitly, if not construct it manually, at least have it in the memory somewhere, this becomes very cumbersome. But this range function is a way to get around that. Each element is computed as needed, and in the end, it behaves as if you had the entire sequence, but you don't have it. Now, if you compare with other languages, and then this is really not Python, in other languages you would have something like that for writing a for. You would have something like maybe a variable that starts from 0 and then goes all the way to 1,000, and each time you go around the loop, this variable becomes the variable plus 1. So as you see, in other languages, the for loop actually acts on one variable that is explicitly incremented each time, and so it's clear that the memory here is not involved except for that one variable that gets modified each time. This is very different from that situation. So in that respect, for those of you who have experience of other programming languages such as Java, the for loop in Python is more like a for each. It's a for each element inside that particular iterable. But as we've seen, this clever workaround of making the iterable itself, the function range, lazy, solves the problem of memory consumption that would be associated with this approach, and therefore we don't have to worry. Practically, it doesn't matter. You're unlikely to spell out a very long list anyway, element by element. As long as you use range for very long loops, you're safe.